here for us at Nixtla. This event is one of, if not the highlight of the year. This community is extremely valuable to us. We have learned so much from that community, and we really want to give back as much as possible. So it's really an honor to be here. It's also extremely joyful for me to have some of the Nixtla team members be here and some of our academic heroes. So obviously I'm not going to speak about 5,000 years of forecasting history, but I wanted to get people excited. So now the title is A Brief History of Forecasting. And truly speaking, it's not really that much of a history. It's more of an opinionated view of certain things that have happened and that I think, if put together, make an interesting, coherent, hopefully coherent story about the field that we are part of and the field that we like to participate in. So the first part, of course, is seasonality. And given that it's early, I wanted to start with some quiz. So if anybody knows what I'm showing at the screen, please raise your hand. If not, I'm going to start picking people at random. Yes, of course. Yes, I mean, it's one of the, if not the oldest Babylonian astronomical diary. And I mean, forecasting in some sense has a very peculiar characteristic, namely that we always somehow hope that the past resembles the future. And some place where the past resembling the future is extremely comfortable and extremely gratifying is when the sun comes up again, or when we see certain patterns of celestial bodies repeating. And this table here was crafted 650 years before our current era. And the basic idea is that they very systematically recorded some observations about celestial bodies. In this particular case, it's the moon. Something very important, I'm not a historian in forecasting, so this is me trying to do a dialogue with the history. So if there's some historian, I would probably advise you to go out and have another talk. But the main idea here is that these people understood something, that if you take enough consistent observations across time, and you start unlocking some interesting capabilities, namely forecasting solar or lunar eclipses, again, 650 years before our era. And later, some scientists found out that there's actually this thing called the Saros cycle, which approximately is 18 years. And if you record by 18 years, then you are able to very accurately predict the next eclipse. So next quiz, what is this? It's in Germany, but it's not German team. Dresden. This is one of the oldest Mayan codices, which is stored in the Dresden Museum. And the Mayan civilization, it's very interesting. It's a very old civilization in Latin America. They suddenly disappeared, but they were very keen observers of the skies. So they also were able to record across many different years and months this simple observation that I graphed here, where orange is a couple of months where you don't see an eclipse, and then you have a yellow, which is an eclipse, no eclipse, then eclipse. And clearly, for all of those working the field, there start to emerge a certain trend. This I think is part of common literature, so someone knows what this is. This is the Nilometer, one of the most important, probably forecasting relics in ancient era. And here again, the idea is simple. You have a river, and that river takes different volumes, and then you record the volumes of the Nile in this case, and that allows you two things. One, which is I think or could be phrased in what we understand as modern forecasting terminology, namely try to forecast future observation based on regular sample past observation. But it also has some multivariate, if you allow me the exaggeration, because it's clear that if the Nile is very high, then crops are gonna drown, and then that's gonna cause a lot of trouble. If it's very down, the same. But if it's at the optimal level, then you know as a government, as a planner, that it's a good maybe time to do some expansion or construction or whatever pharaohs did when crops were good. And this is a clear question for some swag. What sort of algorithm are we seeing here appearing almost 2,000 years before our current era? Absolutely, the seasonal naive, which you're going to see some commercials like throughout the presentation about the open source that we're doing. It's part of the stats forecast library. Also, you should be able to code a seasonal naive by yourself. It's not that hard. But if you don't want, you can always use ours. And I think now we also support certain probabilistic calculations on seasonal naive, which is not trivial. But I think it's very interesting that our field has such a clear origin in the origins of, let's say, human civilization. I also find it quite frustrating that this algorithm is still one of the hardest to beat every time we publish new state-of-the-art algorithms. Then there's another family of ancient ways of trying to approach uncertainty and make decisions. One of the oldest ones is, and please excuse my horrible Chinese pronunciation, but you have this oracle bones of the Shang dynasty, and the idea was that it is probably one of the oldest systematic time series records, and the king or the governor had the chance of do yes or no predictions, like is it going to rain, are we going to go to war, and then he wrote that thing into the plate, and then they put it in the fire, and it broke somehow, and that revealed some sort of omen. The interesting part, besides the like mystic forecast or whatever, is that there was someone that after that happened, it inscribed like years later, months later, if that thing happened or not. So you had some sort of accountability system of whether the king was or not a good forecaster, which is interesting because theoretically speaking, if you repeat that long enough in a bounded setting, you can approximate a sort of interesting forecast. The other very interesting example of historic forecast is the temple of Apollo, particularly Delphi, where you had this priestess called the Pythia, which interestingly enough, it's called like that before because it was believed that below the floor of the Pythia there was this very huge serpent, and that's where the name Python comes from, which again is ironic because despite the wonderful efforts of the R community, I think now Python is the most used language for forecasting in the world. So I do find it funny that there are some obviously coincidental similarities. And the idea here was simple. There were some interesting gases involved where people got some trances, and Greeks have a very interesting sense of forecasting and future and tragedy. And very often it happens that while you know or ask for the forecast, and you fulfill that tragedy by yourself. So there's obviously the classical tragedies of Oedipus, that everything happens because he's trying to avoid what he was told was going to happen. But there's also Croesus who went to the oracle, and he was very happy because he got the notice or the forecast that he will destroy a great empire. And then he didn't. The problem is it was his empire. And the Greeks have this very, I think, subtle thing for tragedy. Nikos can tell us more about the ancient history. And what sort of forecast is this, which is also part of not the forecaster's toolbox, but it comes before that chapter in a very famous book. This is judgmental forecast. And obviously, as practitioners, we try not to rely that much on judgmental forecast. But I think we constantly, and I have been speaking about this with different people in the workshop, there's always an element of people receiving those forecasts and having opinions about those forecasts, being reliable, being not reliable, agreeing or not agreeing. And there's always, of course, a certain person in a certain organization that somehow feels, has a better insight. What's the name of your blog? Yeah. Some people think they have better hindsight because they have more experience, or I'm not targeting you, of course. But so I think judgmental forecast is also an interesting principle that still influences how we take decisions and how we approach the quantification of uncertainty in our field. So now I'm going to fast forward 2,000 years because I do set a brief history. I was pleasantly surprised. Valerie released this new Mastering Modern Time series thing. And the first chapter is very historic. He spends 30 pages speaking about all the things that I'm going to miss and the Middle Ages and trying to forecast weather and some, of course, Russian academics like Markov and the whole thinking about how you think about sequences. But it's interesting. I also skipped it because in my interpretation, most of what he claims is forecast, I think is more like casual reasoning, like if I know that the pressure is going down, then there's a certain probability of rain, which in my opinion, of course, is a forecast in the sense that it's going to rain, but it's not a forecast in the sense of, okay, I have my white hat, and that white hat is composed by the past observations that I have seen with or without exogenous variables. But okay, we're now, we left Babylonia, the Yucatan Peninsula, and Egypt, and we are around 2,000 years into the future, and we hear this thing. We hear that some researchers are working in fields like economics and finance, and they are trying to forecast different phenomena, different aspects of reality. They are putting a lot of effort, a lot of thought into explainability, into understanding models. But then, as all good stories, there's someone that challenges that idea, and some new players, equipped with maybe some new mathematical intuitions, start claiming that they can do better forecast, even ignoring the underlying theories, maybe even because they are ignoring the underlying theories, and they don't really care about explanation. They just focus on accuracy. And I'm trying to find one of the deep learning colleagues here to ask him if that sounds familiar, and put him on the spot with the third question, namely, which decade do you think we are, and who do you think is responsible for this new tradition that focuses on accuracy and not necessarily the mechanics or the explainability of the phenomena? This is something that I want someone to answer. I'm not going to answer that. Unless, of course, we speak like 2 minutes in silence, then I will do it. Who are we speaking about here? We'll put you on the spot, Nikos, because we had an interesting discussion about, or we mentioned it. Yeah, I'd like to mention some names. I mean, so there's or schools of thought. I mean, you don't have to get personal.
I would say forecasting competitions in general has forced a bit the direction.
Like the new deep learning practitioners, against something like that. Yeah, you are completely right, and that could be an answer. And some of the critiques that these people are getting is that they are relying on maybe things that they don't really understand, sophisticated, maybe even obscure mathematical forecasts that were not seen before, questionable model foundations, over-formalization, absence of causal interest. And these are the usual suspects that were challenging all economical theories many years ago, namely, of course, Box and Jenkins, who I think did something very interesting. And if you remember the history, well, a lot of people working in economics trying to model how economics works, trying to make all these different macro, micro assumptions, and things became really complicated, and we know that economists like to complicate stuff, and when they do, the models are simple and they don't really have a lot of explanatory power. And then something very interesting happened. This new school of thought that was somehow focused on mere autoregressive, or almost mere autoregressive values, started creating very accurate forecasts that challenged the whole status quo of how we think about certain phenomena, like macroeconomic forecasting. And it's interesting because I always think a good revolution has to be somewhat publicized. It needs a medium. There's, of course, Marat in the French Revolution, and we can name many other examples. And I think the medium that gave a very interesting voice to this new school of thinking that was challenging what, probably it's wrong, but this mechanistic or explanatory approach to macroeconomic phenomena was precisely the Journal of Forecasting, which here we have the first volume published in 1982. If you remember, and if my hobby historic efforts are not correct, it's very close to the original publications of the Box-Jenkins method, and of course the ARIMA. And it's interesting, if you actually read that first journal, they speak about those new methods as, they have like, I think something like experts and econometrics, and then they have time series. So there's a huge difference between econometrics being more this macroeconomic thing, and time series being this new kid on the block doing this mathematical approaches. And it's, I mean, for me, it's fascinating because this piece of paper that we see scanned here is what somehow started everything that is now here. One of the editors had your last name, but it didn't match on the ages. So it's, I think it's very, very interesting. And of course, I think we all owe a lot of gratitude to the people that made that possible. I don't know all the names, but of course, Makridakis, when he started the M1 and the journal. And also, true revolutions transcend their time, and they do leave a mark in our histories. And in my opinion, two of the biggest marks that started, and it wasn't, of course, only Box and Jenkins. There's a whole tradition around it, but I don't have that much time. First one, of course, is the Monash School of Thought, and the other one is the Lancaster School of Thought, that are, of course, very related, and I think have been creating fantastic work that is very aligned in that tradition of thinking. There are some people that represent that school of thought, but now live in Sweden or whatever, but it's all over the place. It's not necessarily geographical, it's more like a certain specific way of approaching time series problems. And you all know this, but of course there's classical examples with the simple exponential smoothing and the complex exponential smoothing and all the different exponential smoothings which you can find in different libraries, of course, in Fable, of course, in StatForecast and other libraries. You, of course, has the Holt and Holt-Winters methods that created a very important dent in our field. And then, in my opinion, you have this interesting moment in time where, continuing with my revolution metaphor, the revolution became then the principles and the practice of a whole set of people doing forecasting, including of course, many of the people at Nixtla. We started studying the field with these books, and there's a long tradition of the second and the third and the first edition. And of course, now we are also very happy that we had the privilege of doing our little effort of work and expanding this wonderful work into Python, and hopefully opening the possibility for more practitioners to follow these ideas. But then, like, stories are always complicated, and while some specific school of thoughts start getting more and more solidified, new things happen around the world. And something like around 1917, Lugano, two German researchers, probably they were at the lake or at the university or something, started thinking about, okay, what if we could solve some of the main problems of this new thing called neural networks? What if we could have a better representation of learning and long-term memory? And they created this idea of the long short-term memory, of the LSTM, which had a massive impact in how we understand audio and how we understand translation. Both of them, I think, were from München, so it's not also surprising that maybe they had issues communicating with other Germans, so that may be casualty. But that's an interesting point in the history, I think, of machine learning in general, but it is, of course, very related to our field in the sense that it is one of the two pillars of some of the new things that are happening. And then it's interesting because although they were first, then 7 years later in Washington, precisely a computer scientist from Shanghai started imagining tree boosting systems that were designed for performance, speed, large-scale classification, and regression problems. And of course, I'm talking about the seminal paper here of DXGBoost, and then the expansion that was also developed in Washington by Microsoft, the LightGBM, which has very similar ideas, but it's faster, it's more efficient. And now we left that part of history, and now we continue our travels, and now we are in 2018, 2020. We skipped around two competitions, so we have the M4 and the M5 competition happening 2018, 2020, and we start seeing something that didn't happen before. Or maybe it did, in the sense that our history is also seasonal. Our history somehow also repeats certain patterns. Some rebellious people starting experimenting with deep learning and mixing it with exponential smoothing and winning the competition, like here Professor Smil, which on a personal note, it was very influential for us at Nixtla, because three of the co-founders did economics and math, so we had this econometrician. I did philosophy, so I wasn't poisoned by that. But the other three were very interested in that idea of econometrics, and I think what you did, Smil, aligns in an interesting tradition where I see, of course, you, where I see Boris Oreshkin, where I see certain group of thinkers that don't necessarily make the split between statistics and deep learning, that they somehow build bridges between the two. And if you see some of the papers that we created, the NPTEX and the NHITS, there is always this underlying desire of trying to get the best of both worlds, trying to get this so-called explainability, which, if we're honest, is decomposition. I don't know if that's explainability per se or not, but it has been called that. But on the other side, this power of global models that have these wonderful characteristics. And it's interesting because we saw first this rise of deep learning. Then, of course, we also had the second place, which was you, with a mixture also of statistics and machine learning, maybe not deep learning, but machine learning. And then LightGBM started winning everywhere, at least every competition. And I think we all have certain opinions of what the conclusion should be. And I think it's not as easy as saying, okay, LightGBM is the best forecasting method. It's definitely the best forecasting method if you want competitions at Kaggle, but then again, Kaggle in itself has a lot of characteristics that might not resemble the real world. To begin with, you always forecast the past, which is always easier. And then you can forecast and forecast and forecast, and if you know how to hack the system, then you can do many submissions, and I think that's more or less what happened with the 5 competition, where I think some very smart Korean student won, but if you see him now, he doesn't even work in the field. I think he's now doing LLMs and working in a different field. So I think that shows maybe that the one side, yeah, LightGBM is extremely flexible if you want to do a lot of submissions. On the other side, it probably also hints to an underlying problem in how do we evaluate forecast accuracy? How do we set up competitions? How do we choose the best methods? And we have all discussed this at different times. How do we go beyond the 30, 40 data sets that we have been using over and over again? Fun fact, I didn't know, but the M1 was also like the M6, where people got 1001 series, and then they had 1 year to forecast. So it was also like future forecasting, not like the 2, 3, and 4. Also interesting, many of the people submitting were doing it by hand, which for me was like crazy. But yeah, I mean, and this didn't only happen in LightGBM, it also happened in newer competitions like the VN1, which was organized by some retailers and some other Kaggle competitions. So that happened when this new paradigm of grading boosting trees started gaining popularity. We started hearing this lion or whatever mythological figure this is expressing itself. And I'm not going to name the person. We have a lot of respect for him, but it doesn't really matter who said it. I just think symptomatic of these cycles that we are experiencing in our field. So after the M5, I think it's the same journal where Makridakis and co analyze and think about the results. And I think Makridakis, not verbatim, but somehow says, okay, we're seeing a new emergence of a dominating paradigm in forecasting. And one of the 2 school of thoughts that I mentioned before starts asking, like, do the results of the M5 competition sound the death knell for trained forecasters? Which I think is a very hard language. Like it's interesting. Will these results lead to demise of forecasters as we know? Will ML tools plugged together by an IT consultant, which I think is like despective, like someone that doesn't really understand the field, with no scientific training whatsoever in forecasting, become the norm and consign us to the dustbin of history? We do not believe so. I think it's interesting because if you're saying that is that this, you somehow do believe that. Like if there's no necessity to express yourself in that way, if you are at least not somehow thinking about it. And we know it didn't happen. And I know it's maybe exaggerated, but I imagine the same people when they were doing economical forecasts, when Fox and Jenkins came, writing very similar texts. And I imagine later other people standing where we were standing, saying something similar about the next thing. And that's why I called this first part of the talk seasonality, because there is an interesting irony in the fact that our field only works under the assumption that things repeat themselves in some way or another. And our history is also somewhat repetitive in the sense that it has cycles. Let's go back to the Germans sitting at the Swiss lake. They did wonderful things at Google, but then they started a whole new revolution in the time series field. A lot of us, a lot of very smart people started thinking, okay, how do we integrate these ideas of sequential thinking, of long-term memory, of deep learning into our field? Of course, team famously with David Salinas and Jan and Valentin created the DPR, which I think historically is very important. Of course, we kept publicating and publishing very important work. We have a temporal fusion transformer, high former, and then you can, I think, make all sorts of conjugations with the former, and there's an implementation of that. There's the NVIDs that I mentioned. We put our paper there for publicity, but there's the NHIT, which was at least used at some point. And if you allow me an intermezzo, while that was happening, something also new for me in the field happened, namely academics and practitioners start discovering social media. And it was at that point where light GBM was dominating on the street, if you want. They were dominating on the Kaggle competitions. I think academia was still mostly, or had like the statistical school had a very strong suit, but more and more people started getting papers into AAAI and ICML and all those conferences, because obviously novelty is easier to sell as a researcher. And then you start having these very interesting fights in the internet where, like, I don't know, how not to use machine learning for time series forecasting the sequel. And you have this Spider-Man meme where it's like, do I really need to use deep learning or machine learning for this problem? And no, probably you don't even need machine learning. And then people questioning the usefulness for these new methods for the field. Then something very interesting happened. I think this is something that we caught by mistake, but Makridakis and team did a very interesting paper where they, together I think with Amazon, or with the help of Amazon, redid the M3 with some deep learning methods. And I don't know exactly how this happened because this particular photo is old, but the same paper, we found it with two different conclusions at two different points in time. So I think at the beginning they found scant evidence that deep learning really works in any sense, but then later they found that the combination of deep learning models performs better than standard models. And I don't think this speaks in any way against the wonderful researchers that we see in the screen. I think it's more a testimony of the weird times that we were living between all the different schools. There's this person, Boyan, who I think nails humoristically the point, and also some of the frustrations that I think that some of us experience in comparison to other fields, like in natural language processing, in computer vision. Is like researchers are like, nah, wow, our models are like, I used hundreds of GPUs and trained with a whole entire set of words in the world, and now my model is extremely powerful. I don't even know if it's conscious or not. And then we're like, oh yeah, I have a new SOTA neural network model, and after 2 weeks it was beaten by some pigeons doing some abacus calculations. And of course that hasn't happened if someone is in doubt. But we have seen seasonal naive again beating some very prestigious, prestigious in the sense that they were accepted in important conferences. There's also some companies like us that the same year, maybe even the same month, we were defending statistical methods and showing that you could beat deep learning methods 25,000 times faster and with a fraction of the cost. And at the same point, we were pushing the NHIT. So we also understand that we did that. And I don't necessarily think it's bad. It's uncertainty is an essential part of our discipline too. What I think shines, because it's different, because that wasn't, there is certain big corporations. And I think particularly Amazon, or at least I'm more familiar with Amazon because of the friends that I have there. But Amazon has a very distinct history. I think they perceived that period of years in a very different way. They started obviously with what they had, the time series models, and they tried machine learning with the random forest. But then they started a very clear path into trusting neural forecasting methods for one of the most essential tasks inside the organization, namely the supply chain optimization. And as you probably know, Amazon is almost a country. They have many different teams, but one of the research teams is the SCOT team, the supply chain and optimization team, which is very secretive because it's what powers the machinery behind. So it's also hard because they for example, the MQ transformer is a very interesting model, but it's very hard to replicate because the code doesn't exist. So it's interesting. But I think what I like to highlight about this particular slide, and I think it's similar in other companies, maybe Zalando is similar, is that I think one of the many differences between Amazon and maybe academia is that, for example, Amazon has 400 million SKUs across, let me say, 100,000 different zip codes. So the piece that they are trying to solve, the problem that they are trying to solve, it's a complete different problem. And then they have to forecast every day. We have been forecasting the 80s over and over again. And we're getting better at forecasting the 80s. But I think that necessity of having something that works at that scale is where I do see a very interesting argument for neural networks being the solution for at least this sort of problem. On the other side, I do still firmly believe that if you are doing small forecasting, why should you even understand what a neural network is and try to fix the hyperparameters? And even if you do, you're going to probably overtrain it and not going to work. But that's part one. Part two is residuals. And to do a very brief recapitulation of my extremely thorough history of forecasting, we had these 4 periods that let's for simplicity's sake split into ancient statistical machine learning and neural networks. And I do understand that taxonomy in itself is problematic, and I don't know if machine and neural networks are different. Don't look at me like that, team. We have read your paper, but for simplicity's sake, let us use this characterization. And then we created this very scientific graph where you have cost on the x-axis. It can be human cost, it can be monetary cost, and then you have some sort of complexity in implementation and maybe the amount of work that you need to do. Maybe also if you start thinking in GPUs being more complex than CPUs, then this also holds true. And I think one of the very interesting blessings that we have as a company that feels very comfortable between academia and industry, and being very active in the open source and helping with our software a lot of different companies, but also academics and also NGOs, is that we have a first row seat to many different problems of many different organizations of many different sizes. And something that we have found, and that's why I spent so much time showing you some relics, is that a lot of people, a lot of organizations, important organizations, still rely on the ancient forecasting methodology. Ancient being maybe moving averages, maybe seasonal naive, a lot of judgmental forecast, and I'm not issuing here any criticism or any value. I'm just trying to make a descriptive observation of what we have seen. Then we see a new set of organizations that do have more resources, that have people that studied maybe other fields, not necessarily something strictly related to time series. Most of them go very often to profit, which I think is in itself a very interesting topic, like how Prophet managed to become, and is still the most used library in the world, and having certain problems. I think it's very interesting. Sean is a good friend of ours, and I mean, he sometimes even says that he feels like ashamed of like having created Prophet, but I have a lot of, at least marketing-wise or UX-wise, I don't know what they did, but it's crazy. I don't know the exact numbers, but I think Fable and Nixtla together don't get the numbers that Prophet has. And then you have certain people that did go to like engineering, so they do understand the concept of autoregressive models and certain like more classical things. And of course, the ecosystem has grown a lot. It's also amazing to see SK Time growing, to see PDM REMA still being maintained, to see new efforts like SK Forecast offering, I think, very good content. The R ecosystem has also grown. So I think that's also different. Like when we started thinking about this problem maybe 8 years ago, 9 years ago, there wasn't that many options. And then, like this new technology, let's remember that the other two things that we were circling are maybe 30, 40 years old. This new technologies are really used very seldom, and that's because it's hard. You need to train the models. You need to do hyperparameter optimization. At some point, we tried to implement it as middle code. It's in C++. It's very complicated, but he promised that he's going to help us port it to Python. You promised. And then you have to deploy it, and you have like to have this new figures called DevOps, and it's not trivial. And of course it's expensive. Like this is a demanded skill, so hiring talent that is able to do that is hard. So let me finalize with what I believe is the trend, which again, remembering your talk, Christopher, sometimes people believe this is a trend, and maybe the trend is otherwise, but this is what we believe is the trend based on very strict data observation. So on the like out there trend is definitely transformer-based architectures and LLMs in general. I was reading, I don't know how trustable the statistic is, but it's definitely an approximation. I think like 70% of the enterprises in the world use in some sort of another LLMs. I think something like 0.5% of the organizations use transformer-based models in forecasting. So this is not, we haven't done the census, but something like that. It's that order of magnitude. That being said, I think, again, as it happened before with other technologies and other innovations in our field, there has been an effort of different research labs to create what we call maybe around foundation models for time series. And foundation models for time series, strictly speaking, are transformer-based models or deep learning-based models that are trained on larger data. But what's really interesting, what I think really exciting and new is the idea of transferability, the idea that you can train on a certain data set and then forecast on a complete different domain, and you get good results. And I think like the most radical example that I have read recently is the Morai paper, where they took images, they put the images in gray scales, and then of course you have 0 and 1, 0 being white, 1 being black, training a model of those time series that were images and forecasting M3. And they got good results. And last year we were lucky enough to get awarded the Practitioner's Prize to explore that idea of transferability. Obviously, we didn't arrive at any conclusion. We just tried to formalize the problem. But I think it's a very interesting problem. Like, what is the underlying structure or the underlying fact that is allowing for something that seems not to have any structure like time series to work? I think the Amazon team did a good job of framing this as the grammar of time. Of course, time doesn't have any grammar, but it hints to this underlying structure that somehow can be learned and replicated. That's on the one side. And then on the more pragmatic side, I think the promise of foundation models is that I do believe, and I think many of you believe that as we start many papers in our discipline, time series are ubiquitous. They are really everywhere. They represent such an important aspect of the operational world. And if that operational world is forecasted in a better way, then ceteris paribus, we would have more efficient systems, and ceteris paribus, that would make life better for everyone, or at least it would be interesting. So there's this dream that foundation models can have an impact that maybe was not available in past iterations of the discipline. Same as with LLMs. And maybe an ad hominem argument is that I think for the first time ever, you see a company, not one, you see many companies, at least two here, which is us and the forecasting companies were there, that are offering this as a service, which couldn't be done before due to the constraints of retraining and it not being really an API-based product. Of course, people have done time series companies. I'm not challenging that. But this is, I think, a new paradigm in the sense that it's a different protocol. It can be unified with MCP. It can be part of this whole new, let's say, automated ideas. So is this the future of forecasting? And personally, I sometimes believe it. I also have to believe it because that's what I'm building with the team. But if we're strict and look at the slides, then obviously this is not the future of forecast. This is just another step in a very interesting field. And our field will continue evolving and changing. And before I finish with what I believe is it's a very exciting surprise, at least for us, here are some things that we do believe can make the ride more enjoyable and maybe even help the field. And that's something that we try to practice, and that's also something that we feel from this community. Namely, try to be kind to each other, try to be humble and curious. And that's something that I want to tell you like directly. Rob, we have learned theoretically so much from you, but also that innate curiosity for the field and that humbleness, it's really inspiring, and it has been very encouraging for us as practitioners. Try to collaborate to each other. I think we're all trying to build in the same direction, even if we don't necessarily agree on how many layers to put on the linear regressions. It's linear regressions at the end of the day. And of course, maybe let's try to use more than 50 or 30 data sets. Maybe let's try to explore some new evaluation settings. And I think there are some good new research on evaluating not only point forecast, but distribution of errors, and evaluating in more than one window, and so on. And now for the last part, and to try to show what we put in the last slide, we have Pablo has an announcement that he let me do at the beginning. So we heard over and over in this conference and in many other similar places that it would be interesting to have more data. It also would be interesting to have more data that maybe we haven't learned by memory. I'm sure that Pablo can forecast now M3 with eyes closed without using a computer. So it would be interesting to have new data. And one obvious, not necessarily trivial and not necessarily unproblematic solution is simulating data. So Pablo came with this name called the Simulacrum from the project that we want to present today. And as of now, Simulacrum is going to be a free repository of 100 gigabytes. We couldn't do the math yesterday of how many series. Did you do the math? Many series, a lot of series. 100 gigabytes, I think it's 220 times the size of the M3 or M4. So it's a lot of series. It's going to be available for free for researchers and practitioners. The idea is that you can use that data for training, for testing, for exploring, It can also be used to saturate your university server. It's up to you. I think I came with the, Pablo explained to me the project and I understood a part of it. I think Pablo is a very brilliant researcher and he always picks very weird, not weird, complicated topics that are untractable and scaling complexity easily. But I was excited about the amount of data and the possibilities that we might play around with it. The only requirement that we ask is that you give credit to Pablo and et al. Because he hasn't told me like what the paper is going to look like, but at least to Pablo. And I'm not going to explain to you how this works. Pablo is going to do that. And I promised I was not going to do that to Pablo, but this whole generation process is like you have these two arenas and they start doing some simulation. So it's some sort of next gen synthetic data simulation. So we would like to propose to call it a Monte Pablo. And Pablo, please, if you could explain, otherwise I'm going to butcher your research.
Okay, hello everyone. This was cooked yesterday. Yeah, 2 a.m. So apologize for this, and I'm also not a morning person. So yeah, well, the idea is about this simulacrum is basically some people that work in time series might agree, some people might have stronger opinions, but there is this very nice philosophy that in time series, that many of the time series in this universe, let's say they can be captured more or less with just a few stylized facts, right? So usually we can think of trend, seasonality, like a periodic pattern, and some autoregressive components that I don't know if they are stylized, but and then we can plug in some form of uncertainty distribution, and then if we, on top of that, we allow all of these components to change over time, or slowly or abruptly, then we can pick many of these data. And in fact, this statement, even though it's a hypothesis, it can be tested empirically if you go to the benchmark dataset that we have and feed our datasets with very simple models that just capture these facts, you will see that they fit the data well. So it is that there might be other ideas that forecast better, but it's not a complexity problem, right? So as opposed to other fields like in computer vision or natural language processing, where we know that we try to put a linear function on that, it will not fit the data well, but in time series this can happen. So the idea here is that, well, I've been doing this for a few years, so the paper is we are always adding new things to the paper, but I don't know, they wanted to have something on that space. I'm happy to provide some simulations. So basically the point is to have a curated, it's a subjective term, data set of simulated time series that it can be used for evaluation. Some of the benefits of these time series are independent. For example, if you think at many macroeconomic indicators, you just happen to be forecasting at the time of COVID, your evaluations might not be very statistically significant. And then it can also help the training, right? Because if you're training on very related time series, it's also might be overfitting very quickly, and it might not generate as well as we might think. And we can do many other things that are kind of difficult with real data. And the point in the theoretical sense is that we have so much size that we can train large models, but we also, with this big size, we can approximate some nice statistical properties or decision theoretic properties of your models, of course, on simulations, but it just depends on also how close to reality are the simulations, but that's for people that care with reality. In academia, we have the privilege of not always having to care about that. So I guess that's it. And I don't know if there is the next slide. Yeah, of course. So I was worried that because the paper has been coming from a few years, that I don't want then to have to explain to my university committee why I'm not producing new papers. But yeah, a lot of people have worked on that idea. I have this suggestion. For example, I had that quote from earlier paper by some people that you might know. They might be even in this room, but basically there is this gratis paper where they were simulating time series, and they leave at, I think, in the final line of the paper as a suggestion that this idea of simulated realistic time series can be used to pre-train deep learners, right? Very accurately pre-train deep learning methods to save time and improve accuracy. And then, of course, Google times FM, this foundation model is also using simulations as part of their training data set, and I believe Amazon Chronos or some of the versions of at least this other foundation model is using that. And there are many others. I just had some pull from memory at 2 a.m. which other main relevant contributors, but there is this, I wanted to quote some statisticians that are working on that space, right? So for example, it can be used, you have many simulations you can use to reduce the bias of your statistical model, which we know in time series is something that happens. And also TAP PFM, which is another foundation model that was adapted to work in time series, and it works quite well. They are also pioneering in this terms of doing models just from purely simulations. And then I'm sure there are many others, and we can possibly go back many years. So anyway, thank you.
I was kindly allowed to go 2 or 3 minutes over the time, so if you ask your questions, if you have any fast, I try to answer fast.
Yeah. Any questions?
Yeah, thank you. I really like this historical of time series. I just want to input a little bit material for you, probably useful for your future presentation. You know, in China, we have this long history of China lunar calendar. I think that is one of the longest forecasting method we are still using for over 5,000 years. It started from the Shang Dynasty. That is different from the solar system. Every month we have very accurate forecasts of which month this comes, like Guyu, that the rainy season is accurate at like 2 or 3 days. Very accurate and long lasting, I think like 2,000 years before BC. The first thing.
That's always the problem with China. It's always before in everything. I'm sorry that I didn't include
No.
that.
You can tell us other occasions.
I'm
The
sorry.
second thing is that I know the complexity thing, and do you recommend people to use TimeGPT?
If we want people to use TimeGPT,
Yeah,
I mean, yes, of course, we want people to.
but it's costly for training it. Yeah,
For academics and researchers, it's free.
I mean, when you train it, if I want to do this type of thing from scratch, it's quite timely.
No, but
Training.
you can use it either as a self-hosted version or as an API. And there are many, which is interesting, there are many researchers from fields that we didn't know, like people forecasting like humidity in the soil, which is something that we normally don't see in the field. Or this wasn't a researcher, but there was some person forecasting river flows and then plotting them on the wall and creating like wall paintings. So what I'm trying to convey is, yes, of course, TimeGPT is our commercial product, but we are very committed to allowing academics to use it, to test it. There has been published papers where they show that we didn't win. The good thing about Nixtla is if you don't like TimeGPT, we have like something like 120 other models, and they are free too. But don't get locked in, as some people were warning in some of the open source companies. No, I'm just joking. You're not going to get locked in. It's MIT. You can do whatever you want.
Okay, my question is very simple. Actually, maybe it relates to Professor Yan Liu's talk. So I have been here these foundation models for quite some time, but many people still wondering what is exact definition of foundation models from your slides, also from Professor Yan Liu's talk and other talks. It seems like we just put many models inside, like system of co-foundation models. Am I correct?
I think
there is no mathematical foundation.
there isn't definitely a formal definition, but I think some of the people working in the field, something that translates across domains, that has more parameters than your average thing, and that has in the title foundation.
Nikos?
Yeah, so thanks for the presentation. This was quite enjoyable.
Thank you.
I will pick a bit on your last slides and also the announcement of Simulacrum. So if I follow your trend, it seems that the way we're doing research has to change in terms of resources, in terms of data, in terms of how the teams are composed. What's your view on that? What's the future looking like for the research teams?
I do believe that one of the things that changed the history of machine learning in computer science and in computer vision and natural language processing was the complexity and the size of the data, because that started allowing for new innovations. And now it's like we are still trying to predict the end missed numbers thing with very sophisticated transformers in our field. So I think that's one point. The other point is I do feel a certain separation between academia and industry. I think in academia, for me, the idea of what is a good forecast is, I come from philosophy, though I always have these weird questions. And what is a good forecast? It's a weird answer, because a good forecast, if you're an academia, is the one that gets you into the conference and gets you quotes and gets you probably tenure at some point. If you're in industry, a good forecast can mean different things. It can be the one that optimizes inventory, but it can also be the one that makes your boss happy. And Bauman has been researching the political aspects of forecasts. So I don't have the answer, but I think it's definitely trying to put. I can tell you what not to do. We can't keep using the same data sets. We can't be forecasting on the same settings with almost always just one window. We have to think more about error metrics. Like error forecast by itself doesn't do shit. If it's RMC or MAPE, there's always like an ulterior function. Tim has explained this very good. It's always about achieving something with that forecast. So it's always a mediated relationship. And in the sense that we understand that, in the sense that we somehow clarify what is a good forecast, and it's definitely not something that nobody has done before and doesn't compare with a seasonal naive, I think that will improve. Right now, the best thing that I can do at this moment is try to do something that wasn't done before, namely put billions of series there, and hopefully there's something interesting there. Like me and Paulo were discussing yesterday, maybe half of it it's non-realistic. Maybe half of it is, but which half and how to find it, it's an interesting question by itself. And now we can start asking it. So don't put me on the spot, Nikos. You're the professor here. You tell me.
All right, so for the interest of time, we'll leave the other questions offline. And let's thank the speaker, Mac, and Pablo again.
And I think Pablo's going to be here if you have questions regarding it.
And on behalf of the local organizing committee and as a co-chair of this conference, I'm